Number 8 on the practice exam. A large software company gives job applicants a test programming ability, and the mean for the test has been 160 in the past. 25 applicants are randomly selected from one large university, and they produce a mean score of 165 with a standard deviation of 13. At a significance level of 0.05, does this indicate that the sample comes from a population with a mean score greater than 160? All right, so one of the first questions that you should be asking yourself when you're doing questions like this is, am I doing a t-test or a z-test? Because we have information about a sample right here, 25 applicants, and the mean of those 25 is 165, and the standard deviation is 13. Because we have the standard deviation of the sample, and because sigma isn't given to us, we use t-test, right? So let's identify all the other information that we're given. Because we're using t-test, the formula is t is equal to x bar minus mu all over standard deviation divided by square root of n. So x bar is 165, right? From the 25 applicants, it's 165. And then it says the mean for the test has been 160 in the past. So that's our mu, 160. And then 13, standard deviation divided by square root of 25. So working this out, we get a t of 1.923 with a degree of freedom of 24. And remember, when we're doing this in the table, we don't get a specific p-value. We have an interval over p-value could be if we do this by hand, right? If we decided we wanted to do this in the calculator, we can do that pretty easily too. Let's turn on our calculator and go to stat, test, t-test. And we have all of our stats. Again, mu naught is 160, x bar is 165, standard deviation is 13, and n is 25. And to identify, we're gonna what we're testing, if it's greater than or less than, it says here, does this indicate that the sample comes from a population with a mean score greater than 160? So we're looking for greater than the mu naught, and then we calculate. And that's how we find p-value through the calculator. But again, if we're using the table, we get an interval. So we get the t 1.923 and we match it with a degree of freedom. So let me just show you that really quickly. With a degree of freedom of 24, we look for where t at 1.963 could be, and it could be between 1.711 and 2.064. So between, and this is a one-sided p, so it's between 0.05 and 0.025 p-value. And in our calculator, yeah, 0.03 is between 0.05 and 0.025. So let's finish this problem. So with a p-value of 0.03, we calculated here, comparing it to an alpha level of 0.05, that's given to us also right here. Because it's less than 0.05, we'll reject the no, right? So our options are, we eliminate A, B, and D right away because it says no with a p-value of 0.0664, we fail to reject. That's not true. 0.03 is significant, so we can reject. So that's why we also eliminate B, because it says we fail to reject. It says here it says here that we do reject, but it gives us a p-value of 0.0664, which is a two-sided p-value. So that's why it's C. Yes, with a p-value of 0.0332, that's what we got. We reject that the mu is 160, the null hypothesis that is 60 or 160. So that's how you do number 8.